Hi, this is Catherine Scott for drillingcontractor.org. I'm here on the exhibit floor of the 2012 SPE ATCE in San Antonio, Texas, with Brian Grayson, Global Manager of Emerging Technologies for Drilling Optimization Services. Thanks for joining us today, Brian.
Thank you, Catherine.
Earlier today at the Weatherford booth, you gave a presentation where you likened not using closed-loop drilling to driving without your lights on a car. Can you explain that analogy a little bit more?
I'd love to. Great opportunity. Okay, when we go into any kind of a well construction design process, we're usually using whatever data is at hand. And this is from offset data when we get it. And the thing is, what we're finding now with all the subsalt, pre-salt type zones that we drill into, the geology can be quite different from one well to another. So we don't always have that exact information needed, so we can make the proper design decisions. So there's a lot of uncertainty that goes into that. Add on top of that, we're drilling into a lot of HPHT exploratory wells. Exploratory means we've never been there before. So there's definitely a lot of uncertainty. So what we can do with our microflux system is we can, as we drill into these zones, we can start to test where the limits are. What are the parameters of that well? So what is the core pressure? We can actually determine that. What is the fracture gradient? We can determine that. So if you think of that narrow window like a road, a curvy road, because the bends, you don't always know where they're at, and you think about going down that road now with your lights on or off. Well, microflux is like putting your lights on and looking around you, seeing the environment, versus let's just hope for the best and we're going to drive it without our lights.
Can you explain the principle of mass balance and how Weatherford uses that in its approach to closed-loop drilling?
I would love to. The principle of mass balance is really a simplistic principle, and that's what makes it so great. And it's also very unique to Weatherford. It's our IP that allows us, and us only, really to practice that means of closed-loop drilling or managed pressure drilling. What it entails is what goes into the well must come out of the well. So whatever fluid we pump into the well, the equal amount needs to come out. So if we see something that's if we see more coming out of the well than is going into the well, that means we're taking a kick. If we see less coming out of the well, that means we're taking a loss. Now I say it's simplistic, but there's some other components that go into it. We take surface back pressure and we take standpipe pressure and a few other measurements throughout the rig, and that correlated together tells us what is actually happening. It gives us that information, as I was mentioning, the core pressure and the fracture gradient and all that kind of good stuff. It's a simple concept, but it's the algorithm and the knowledge that goes into it that really does tend to make it unique and a powerful tool.
Okay, and I also saw in your presentation that you said an operation is 470 times less likely to have a blowout if it's using closed-loop drilling. Can you explain kind of how you got to that
Okay,
number?
that's a good one. 470 times. I say that a little bit tongue-in-cheek because it is a big number. Now what I did is I took an existing analysis that was developed or actually put together by DNV just post-Macondo that kind of explained the risks that we were looking at from a well control event. And I added in our system and how we are able to affect by once again being able to identify that core pressure and fracture gradient, and how we can make determinations, and if we do see an event, we can capture it, control it, and really that's what makes the big, well, stepping back a little bit, without a closed loop system with microflux, I was able to see from the DNV study that you are 1 in 4 chance that you will have to go to BOPs on a conventional well. Well, just the big impact that microflux makes by having that knowledge is what makes that factor of 470, really impactful. And 470, it could be 10, it could be 1,000. The thing is, it's orders of magnitude above and safer than what you can do conventionally.
Okay, so looking at challenges, what do you think are industry's biggest challenges toward a wider application of closed-loop drilling, and then how can the industry address those challenges?
Well, closed-loop drilling, we really started defining that after we started doing a lot of managed pressure drilling operations. Now, managed pressure drilling traditionally was known as a technique that allowed you to drill a well. it had very little to do with really safety. It was just, we can't drill this well any other way, we're going to use MPD. Well, those same key core technologies have now really given us a lot of benefits towards process safety. Once again, being able to identify what you're drilling into. And there's a big safety component that isn't truly realized yet. So as soon as the industry starts moving past just the drillability aspects and sees it for being a safer way of drilling, then we're really going to see a major growth in the uptake.
Okay, and then for the future, what do you think the future implications of closed-loop drilling are in deep water drilling?
Well, everything's related to Macondo these days, especially when we talk about deep water. The post-Macondo report mentioned one of their first statements was that offshore rigs, should have a better means of early kick detection. Well, closed-loop drilling, and specifically microflux, gives really the industry's leading method of kick detection or event detection downhole. So really that is going to be, I would say, one of the biggest benefits that we can lend to the deep water offshore community. Just having a better way of identifying when something's coming and being able to react to it. I would think that would be the most impactful thing that we're going to see in the near term, and I believe in the long term.
Great. Well, thanks so much for joining us today, Brian.
Thanks, Catherine.
This has been Catherine Scott for drillingcontractor.org here at the 2012 SPE ATCE exhibit floor. Thanks for joining us.